Hello friends. In the previous video we saw what is resistance temperature detector or resistance thermometer. Now we'll know about its construction, its basic construction. So it basically consists of a non-conductive cylinder or a strip, let's say a strip generally of mica, okay, on which the metal wire which is called the temperature sensor, that metal wire is wound, okay. The temperature this wire is wound, okay. So this can be a cylinder also, basically a cylinder of mica around which the wire is wound, okay. Now this full system, the wire and the mica strip or the mica cylinder, this system is enclosed in a protective tube of pyrex glass, or we can say it can be stainless steel in case of industries, or in for laboratory, means in lab or such small things, we use pyrex glass, or nickel or stainless steel are used in industries. So this glass, okay, pyrex glass coating. Why this protective tube is given? It is enclosed in this protective tube to avoid the corrosion of resistive element, okay, to protect the wire or the system from corrosion. It is protected, it is given protection of a tube which is generally pyrex glass in case of lab, or it can be stainless steel in industries, okay. So this was the basic construction. Now this connection is taken, okay, the wire end of the wires are taken and connected to a Wheatstone bridge, okay. We know this Wheatstone bridge, and the resistance is measured here, okay. Now this was the basic construction. Now we will discuss about the working, the basic working, how it works, okay. uh, so this was the basic construction. Now for working, we previously discussed that the formula is RT equals to R reference into 1 plus del T into alpha, or we can write alpha into del T, alpha into del T, okay. So we discussed what is RT. RT is the resistance of the resistance at a given temperature T, okay. R reference is the temperature, the resistance at the reference temperature, okay. That we can take 0 degree Celsius as the reference temperature, and this alpha is the coefficient that we know, coefficient of the wire. If we take platinum, then it will be the uh, it will be the temperature coefficient of the resistance. Okay, it will be known to us, the temperature coefficient, and this del T is the difference between the reference temperature and the temperature to be measured. Okay, so we put this tube in the place where temperature is to be measured. Okay, then we know what we know. We first know the um, we first know the temperature coefficient of the resistance, that is alpha. Okay, now we know the reference temperature, that is the the reference resistance at the reference temperature, that is R ref, R reference. Okay, that we know because if you take platinum, okay, so at 0 degree Celsius, what is its temperature, what is its resistance at 0 degree Celsius, we know it. Okay, then now we know the temperature difference between the reference temperature and the given temperature, what we have to measure. Okay, that we will measure first. We measure the resistance at RT. Okay, we measured the resistance at RT and the resistance at R reference. Okay, this we know, so we will measure this. By help of this, we will get the reading at temperature to be measured. The resistance is known. Then we know the resistance at the reference temperature. We know the coefficient of resistance. Okay, so we will get del T. From this equation, we know these three things we will be knowing. So we can get this del T. What is this del T? Nothing but the temperature difference between the temperature to be measured and the reference temperature. So from this we will be getting del T. Okay, del T we will be getting. Now what is del T? Nothing but the temperature difference of the temperature to be measured and the reference temperature. So reference temperature we know, okay, equals to del T. The reference temperature we know, del T we found from the equation, so we can take out the temperature to be measured.